Welcome back. In episode 2, we saw the SEE energize the generator's field and regulate its voltage forever. But before any of that matters, something still has to physically turn the shaft. That's the SFC's job. Today, we go inside it and see one of the cleverest tricks in power engineering. Here's the secret. A generator and a motor are the same machine. Feed a synchronous machine three-phase power, and it spins as a motor. Let it be spun by an outside force, and it becomes a generator. Same iron, same windings, just a different direction of energy flow. Since the SEE has already energized the rotor field, all the SFC has to do is feed the stator with AC power, and the whole generator turns into a motor ready to spin the turbine. But there's a catch. The grid only supplies one fixed frequency, 50 Hz. You can't start a motor at full frequency from a dead stop. So the SFC does two conversions. First, it rectifies incoming AC into DC. Then, it inverts that DC back into AC, but now, at whatever frequency it chooses. This is called an LCI, a load commutated inverter. And here's the elegant part. It uses the generator's own voltage to help switch its own thyristors. That's only possible because the load is a synchronous machine. Now watch the ramp. The SFC starts at near zero frequency, and the shaft begins to turn. As frequency climbs, so does speed. 10%, 15%. At around 15 to 20% of rated speed, ignition. Fuel enters the combustor, and the turbine begins producing real torque of its own. Once the turbine can sustain itself, the SFC's breaker opens, disconnecting it completely. Its work is done, and it stays idle until the very next start. The SEE keeps running. The SFC goes quiet. That's the full picture. Two systems, two completely different life cycles, working together for less than 2 minutes at the start of every run. Next episode, the full startup sequence, second by second, with real control signals. Subscribe, and I'll see you there.